Hello, this is Shreya Kumar Mat. My present topic of presentation is shear force distribution in helicopter rotor blade. So in the introduction, what is rotor blade? Rotating wing in the main rotor system is known as a rotor blade. So why structural loads matter for rotor blades? So loads like shear, bending and torsion. So today we are going to focus on the shear force distribution along with the blade span, how it arises and why it is important. So what is shear force in the blade? Shear force is the internal force parallel to the cross sectional that tends to slide one part of the blade past another. In rotor blade, shear arises due to aerodynamic loads, lift, drag, internal loads, centrifugal force and structural reactions. It acts along the span from the root to tip and it is cross section of the blade. Shear often accompanies bending movements. The bending causes internal shear disturbance. So, in next page we can see source of loads on rotor blades. So, aerodynamic lift distributed along the span produces upward force like bending plus shear force. Centrifugal force due to the rotation acts outward along the blade span producing axial loads but influences shear and bending. Inertia force during maneuvering, flapping, lagging produce additional loads. Structural reaction at the hub not carries the blade loads and transmits them to the mast, as you can see in the graph. Typical shear force distribution along with the blade. The shear force is the highest at near the blade root and decreases towards the tip. Why? Why this happens? Because the root must carry all the loads accumulated from the tip inwards. The magnitude of the shear force QR at the spin-wise section is roughly the integral of distributed loads from the station to the tip. Design implication: root region experience the greatest internal shear stress, thus root must be structurally strongest. Relation between shear bending and torsion. Shear force Q is related to bending moment via derivative in simple beam theory. Torsion, twisting also influences structural design and interact with the shear and bending, especially in composite blades. For rotor blades, combined loads mean design must check shear, bending, torsion and fatigue simultaneously, factor affecting shear distribution. So, span-wise variation of lift, aerodynamic loading. More lift near middle span may less tip, blade geometry, chord length, twist, airfoil space, shape. In example, twist to analyze lift, reduce extreme loads. Material, structural design, composite spar, sandwich construction influences shear capacity. In summary, shear force is the rotor blade arise from aerodynamic internal and structural loads. Shear distribution is highest at the root and decreases towards the tip. Understanding shear is a critical for blade structural design, material choice and fatigue life. Designers adopt geometry and material strategy to manage shear loads, twist, composite spar. Monitoring and maintenance are vital because high shear regions are prone to fatigue and damage. Thank you.